झालं देते लगेच.
Okay, good afternoon, all of you. May I audible?
Yes, ma'am.
Okay, please wait for 2 minutes. Only 42 students are joined. We will start lecture within 2 minutes. Okay, good afternoon, all students, and welcome back to lectures in Introduction to Solid Mechanics. So we will take revision within 5 to 10 minutes, and then we will start today's lecture. Okay, in previous lectures, we have studied what is meant by stress. So stress means resistance, force per unit area is called as stress, and stress is denoted by using sigma, and the unit of stress is Newton per mm square. After that, we have studied the types of stresses. basically there are two types of stresses, which in that one type 1 is direct stress or normal stress, and type 2 is shear stress. Okay. So already we have studied what is meant by direct stress. Direct stress nothing but the stress or the force which is applied perpendicular to the cross section or parallel to the axis. This stress is called as direct stress. Direct stress, either it may be tensile or it may be compressive. Okay, after that we have studied what is meant by shear stress. So shear stress means force applied along the tangential area. So this stress is called as shear stress. Okay, after that we have studied what is the difference between normal stress and shear stress. In normal stress, applied force is exactly perpendicular to the cross section, and in shear stress, applied force is along the cross section or tangential to the cross section. This is the basic difference. Okay, after that we have studied next concept, that is what is meant by strain. So strain means change in volume or change in dimension to the original dimension. Okay, change in dimension to the original dimension. So strain is denoted by using epsilon, and formula is delta upon L. Okay. After that we have studied types of strain. There are two types of strains, direct strain and shear strain. Same likewise types of stresses. So if applied force is exactly perpendicular to the cross section, at that time we will say direct strain. Okay. And shear strain means you have to measure this angle. That is, at an angle, at that angle the body takes shear off. So you have to measure this angle. So this is called as shear strain. Now we will see next point, that is structural properties. Okay, next point is structural properties. So please write down next point, structural properties. Structural properties. Okay, please write down first. First property is elasticity. Okay, first property is elasticity. So already you have studied it. There are some basic properties, likewise elasticity, plasticity. Okay, so today we will see some properties related to structure. So that's why I have written here structural property. In that first, write down elasticity. Okay, first we will see what is meant by elasticity, and then we will see what is the opposite of this elasticity. First you write down definition, then I will explain. So write down definition. Property by virtue of which property by virtue of which virtue of which virtue of which materials regain materials regain materials regain materials regain their original shape their original shape their original shape and size their original shape and size after the removal of deforming forces after the removal of deforming forces after the removal of deforming forces. Okay, now I will explain what is meant by elasticity. See in this figure. Okay, See, in this figure, they have taken a rubber. Okay. And on that rubber, they are going to apply load from both directions. Okay. So, they are applied load on that rubber from both directions. After removal of load, this rubber gets original shape and size. This is called as elasticity. Okay. So what is meant by elasticity? Suppose you have taken any material on that material. Okay. Suppose I have taken this pen and now I am going to apply load on that pen. After removal of loading, this pen gets their original shape and size. Is it possible?
No, ma'am.
No. Okay. So rubber or likewise rubber materials, when you are going to apply load on that material, this material regains their shape, original shape and size. So this property is known as elasticity. Okay, this material is known as elastic material. Now you tell me what is the opposite of this elasticity?
Plasticity.
Plasticity.
Before that, something before plasticity, one property is there. So this is called as a rigid material. So material is rigid. The opposite of this elasticity is called as rigid or rigidity. Okay, so this is called as rigid. So what is mean by rigid? So rigid material म्हणजे काय असेल? Okay, what is mean by rigid? If there is no any deformation, then this is called as rigid material. Okay, so I have taken this pen and I am going to apply load on that pen in both directions. So when after removal of force, this pen does not get their original shape and size. Okay, so this is called as rigid material. Okay, got it? Opposite of this elasticity, rigid. So what is mean by rigid? Deformation does not occur. This is called as rigid. Okay. So whether body is in pure rigid or elasticity, म्हणजे body is pure rigid किंवा elasticity मध्ये असू शकते का हो? ते कशावर डिपेंड असेल? Whether body is in rigid or elasticity. So it is depend on application of loading. It is depend on application of loading. Now I will tell you one example. Suppose I am hitting on a wall. I am hitting on a wall, or I have taken suppose this diary. Okay, this diary, and now I am going to apply load, or I am hitting on this diary. Now you tell me in which material deformation is occur, in diary or in our skin of hand? Okay, once again I will explain. Now I have taken this is diary and I am going to apply load, or I am hitting hand on diary. I am hitting hand on diary. At that time, in which material deformation is occur? In diary or our hand skin? So deformation is occur in our skin. So property is elastic property is in our hand and rigid property is in diary. Now I will take another example. Okay. Now I am going to hit on that diary by using hammer. So now you tell me which material is going to deformation or which material is going
Diary.
Diary.
Yes, good. So elasticity and rigid is depend on application of loading. Okay, depend on application of loading. I am hitting hand at that time amount of loading is low. At that time amount of loading is less. So deformation is occur on my hand. But now I am going to apply load by using hammer. At that time deformation will occur in this diary. So this elasticity and rigidity is depend on application of loading. So simply you please remember that Elasticity means property by virtue of which material regains their original shape and size after the removal of deforming force. So this is called as elasticity, and for that best example is rubber. Okay, got it? If you have any doubt, please ask me. Otherwise, we will move towards next point. You have any doubt?
No, ma'am.
Okay. Please write down next property. Homogeneity. Write down next property. Homogeneity. Homogeneity. Okay, first you write down definition, then I will explain what is meant by homogeneity. So please write down definition first. Okay, I will read a definition. Same composition, same composition, same composition throughout the body, same composition throughout the body. Elastic properties are same. Elastic properties are same. Elastic properties are same. Elastic properties are same at every point. At every point in a body. In a body. In a body. This is first one definition. Or for that, or please write down another definition. If elastic properties are same at every point at every point in the body this is called as homogeneity. This is called as homogeneity. For that, I will draw figure here and then I will explain. Okay. So I have taken one body. This is rectangular member. Okay, I have taken a rectangular body. This is suppose a rectangular body. Okay. Now I have divided this body in three parts. So suppose this is part 1, 2, and part 3. Now I am going to check elastic property. Elastic property means you have to check modulus of elasticity or Young's modulus, Poisson's ratio, shear modulus. Okay, likewise. So now you remember only elastic properties. Afterwards, we will see which are the elastic properties. Okay. Now I will explain here what is meant by homogeneity. So for that, I have taken this is rectangular member and I have divided this rectangular member in three parts. Now, so suppose strength of this rectangular member at top is 10 kilonewton per meter square. Okay. At middle portion 10 kilonewton per meter square and bottom portion 10 kilonewton per meter square. So this body or this material is called as homogeneous material. That means if we have to take elastic property point to point. Suppose you have check here. Suppose you have to check here. So at every point, if elastic properties are same, this is called as homogeneous material. For example, suppose I have taken a bag of sugar. Okay, a bag of sugar. Now I have eaten sugar at top. So sugar is too much sufficient. Okay, साखर काय असणार आहे तुमची टॉपला जेवढी गोड असेल तेवढीच काय असणार आहे तुमची मिडलला पण गोड असणार आहे तेवढीच तुमची बॉटमला पण असणार आहे. सो elastic properties are same at every point. So this property is called as homogeneity. Got it? If you have any doubt, please ask me regarding this homogeneity. Please remember, homogeneity means elastic property you have to check at every point. Okay. You have any doubt?
No, ma'am.
Your writing is over. Shall I move towards next point?
Yes, ma'am.
Yes.
Write down third property. Third property, isotropy. Third property, isotropy. Third property is isotropy. First, you write down definition, then I will explain. If elastic properties are same, if elastic properties are same, elastic properties are same in all direction, this is called as isotropy. 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 Please draw this figure also. Okay, this one figure also draw. Okay, I have taken this cube. Okay. Now I am going to check elastic properties at x direction, at y direction, at z direction. Suppose here, also here, and here. So isotropy means if elastic properties are same at every direction. Okay, see here, at every direction. Means we have to check elastic property at each and every direction. म्हणजे तुम्हाला कुठल्याही डायरेक्शनला जर प्रॉपर्टी चेक करायची असेल आणि ती प्रॉपर्टी जर सेम असेल at every direction, then this material is called as isotropic material, or this is called as isotropic. So one basic difference between homogeneity and isotropy. So in homogeneity, we will check elastic properties with respect to point. And in isotropy, we will check elastic properties with respect to direction. Elastic properties are same in both properties. Okay, but in homogeneity, you have to check point wise, and in isotropy, you have to check direction wise. Please remember this basic difference. Okay, so what is meant by isotropy? If elastic properties are same at every direction, this is called as isotropic. This material is known as isotropic material. This material is known as isotropic material. Okay. Now I will tell you example. So isotropic material means all types of metals. All types of metals. Suppose iron, steel, gold, likewise. Any type of metal is the example of isotrope. Okay. But if you have any doubt in this isotropy, shall I move towards next point?
Yes, madam.
Okay. So please write down last property, anisotropy. Last property is anisotropy. 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 If elastic properties are, if elastic properties are, if elastic properties are different, elastic properties are different Elastic properties are different. Elastic properties are different at every direction. At every direction. This is called as anisotropic. 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 Okay. After that, please write down example of anisotropic. Example. So example is wood. Okay. Wood and composite materials. Composite material. Composite materials. So we will take one example of this composite material related to our civil engineering. Suppose I have taken this is one beam. Okay. So this beam is casting by using two materials. Which two materials are used for casting this beam? Anyone please? Which two materials are going to use for casting this beam? Okay, I am expecting answer from diploma students.
Concrete and
Concrete and
reinforcement.
reinforcement. Good. So this beam is constructed by using reinforcement. Reinforcement in form of steel. Okay. Suppose reinforcement in the form of steel, and here concrete is placed. So this is the example of composite material. Now, anisotropy. Anisotropy means elastic properties are different at every direction. Now I am going to check strength along this direction. Okay, along this direction. So steel is placed along this direction, and I am checking strength also. Placing of direction steel at that time strength is more. At that time strength is more. But I am checking strength perpendicular to the position of steel. Perpendicular to the position of steel. At that time strength is less. At that time strength is less. So here elastic properties are different. So this is the example of anisotropy. Okay. Please remember one thing. बघा जर आपण स्टील ज्या डायरेक्शनला प्लेस केलेला आहे त्याच डायरेक्शनला जर स्ट्रेंथ चेक करत असेल तर ती तुम्हाला स्ट्रेंथ ही जास्त मिळणार आहे. पण आपण स्टील जर प्लेस हॉरिझॉन्टल डायरेक्शनला केलेला आहे आणि आपण व्हर्टिकल डायरेक्शनला जर स्ट्रेंथ चेक करत असेल ऍट दॅट टाइम स्ट्रेंथ विल बी लेस. सो हियर elastic properties are different at all directions. So this is the example of anisotropy. Now, if you have any doubt, please ask me. Otherwise, we will move towards next point. Okay, I think anybody have any doubt? So I will move towards next point. So that four properties are the structural properties: elasticity, homogeneity, isotropy, and anisotropy. So elasticity means material going to deformation. In that material, deformation is occurred. So this material is called as elasticity. Then homogeneous or homogeneity means elastic properties are same at every point. This is called as homogeneity. Isotropy means elastic properties are same at every direction. This is called as isotropy. Okay. Now we will move towards next point. Write down next point. Most important point, Hooke's law. Next point is Hooke's law. Next point is Hooke's law. Next point is Hooke's law. Okay. Now see in this figure. Okay. So on x-axis strain is plotted, on y-axis stress is plotted. Okay. From O to A, line is linear. From O to A, line is linear. And from A to B, B to C, and C to D, line is in curvature nature. Line is in curvature nature. Okay. So if the line is linear, then elastic relationship between stress and strain, this is called as Hooke's law. Okay. So when we say line is linear, suppose our line is straight line. Okay, not it is in curvature, so this is linear. Okay, so if line is linear and is in here, elastic relationship is there, so this is called as Hooke's law. Okay, so Hooke's law states that, within elastic limit, stress is directly proportional to the strain. Within elastic limit, stress is directly proportional to the strain. Okay. See here, from O to A, you observe stress is increased and by same amount, strain also increased. Okay. That's why here stress is directly proportional to the strain. So stress is denoted by using sigma. Stress is directly proportional to the strain. Now I have to remove this directly proportional sign. At that time, one constant will be there. So stress, which is equal to E into epsilon. E into epsilon. Okay. So E, which is equal to stress upon epsilon. Here E means, anyone please, काय असेल हो ही E म्हणजे काय असणार आहे? E means
Proportional constant.
proportional constant, or this is called as Young's modulus. Young's modulus, or also this is called as modulus of elasticity. This is called as modulus of elasticity. Modulus of elasticity. Modulus of elasticity. Okay, see here. Here one equation is applied. One line equation. Line equation is y, which is equal to mx plus c. Okay, line equation is y, which is equal to mx plus c. If c, which is equal to 0, if c, which is equal to 0, at that time what is remaining? Y, which is equal to mx. So y means stress. Y means stress. M means E, and x means epsilon. So y, which is equal to mx, I will write here y, which is equal to mx. So sigma, which y, which is equal to mx. So sigma, which is equal to E into epsilon. E into epsilon. This is the basic concept behind that. Okay. So this line represents slope of the line. This line represents the slope of the line. So in between O to A, line is linear and stress-strain relationship is elastic relationship. That's why Hooke's law states that within elastic limit, stress is directly proportional to strain. That's why I have written sigma directly proportional to epsilon. So you have to remove this directly proportional symbol. At that time, sigma, which is equal to E into epsilon. So this E is proportionality constant. Modulus of elasticity. Okay. So E, which is equal to sigma upon epsilon. This is our Hooke's law. Now this graph shows different values for Young's modulus for different materials. Okay. In this graph, on y-axis, stress is there, and on x-axis, strain is there. Okay. So this first line indicates value of modulus of elasticity for biological tissues. This second line indicates the value of Young's modulus for rubber. Okay, for rubber, Young's modulus is 10 raised to 6. Then this line indicates value of Young's modulus for plastics. So for plastic material, Young's modulus or modulus of elasticity is 10 raised to 9 Pascal. And this line indicates Young's modulus for steel, E, which is equal to 10 raised to 11 Pascal. Okay. This is most important graph because of any competitive examination, they will ask values of Young's modulus. Okay. At that time, please remember that the value of Young's modulus is high for steel material, and low for gels or biological tissues. Okay, gels or biological tissues. In examination, it may be asked question, which material has a high Young's modulus? They have given options steel, plastic, rubber, or biological tissue. At that time, you have to remember that the value of Young's modulus for steel is high as compared to other materials, and value of Young's modulus for biological tissue is low as compared to other materials. Okay, what is mean by Hooke's law? Within elastic limit. Okay, within elastic limit, stress is directly proportional to strain. When we say stress is directly proportional to strain, stress is increases, at that time strain also increases by same amount. So this is called as directly proportional. So this line is linear and this line shows slope of this line. Slope of this line. So please write down this Hooke's law. Hooke's law states that within elastic limit, stress is directly proportional to strain. And after that, write down mathematically, stress is directly proportional to strain. So sigma, which is equal to E into epsilon. So E, which is equal to stress upon epsilon. And after that, below, write down where sigma, which is equal to stress, E, which is equal to, already we have written here, Young's modulus of elasticity or proportionality constant, and epsilon, which is equal to strain. After that, draw this figure. Okay, this figure only. Suppose I will say here figure A. Draw this figure only. After your writing is over, let me know. We will move towards next point. If you have doubt regarding yes,
दोन्ही पण ड्रॉ करायचे.
no, you draw only figure A. Because of this second figure, we will see in next point. That's why you only draw this figure A. After your drawing is over, let me know. We will move towards next point.
Okay.
Okay, if your writing is over, shall I move towards next point?
Ma'am, अजून एकदा figure explain करा.
Figure 1.
Yes, ma'am.
Okay. This figure A shows, okay, I will highlight so you able to see. So this figure A shows strain on x-axis and stress on y-axis. Okay. And these four lines are shows value of Young's modulus for different materials. Okay. So this first line shows the value of Young's modulus for biological tissue. म्हणजे biological tissue जे असणार आहे त्याच्यासाठी Young's modulus किती असेल 10⁵ Pascal. Again, this second line shows value of Young's modulus for rubber material. Okay, so Young's modulus for rubber is 10⁶ Pascal. 10⁶ Pascal. This third line shows value of Young's modulus or slope of this line for plastic material. Okay, so for plastic material, the value of Young's modulus is 10⁹ and this last one line shows the value of Young's modulus for steel, and the value of Young's modulus for steel is 10⁻11 Pascal. From that figure, you have to remember that only the values of Young's modulus for different materials. Okay, on that, any one question is asking, so for which material have high Young's modulus? So please remember, for steel have high Young's modulus, and for glass, gels or biological tissues has low Young's modulus as compared to steel, plastic and rubber. Okay, now got it?
Yes, ma'am.
Okay. So already we have written here E, which is equal to sigma upon epsilon. So after that, write down next point. I will clear all drawings and we will move towards next point. Okay. So please write down next point. Young's modulus. Young's modulus. I will write here. Young's modulus. Young's modulus, or this is also called as modulus of elasticity. Modulus of elasticity. Modulus of elasticity. Modulus of elasticity. So first write down definition. It is the ratio of normal stress to the normal strain. It is the ratio of normal stress to the normal strain. Normal stress to the normal strain. Okay. So this Young's modulus or modulus of elasticity is denoted by using capital E letter. Okay. So E which is equal to normal stress. Normal stress is denoted by using sigma divided by normal strain is denoted by using epsilon. So E which is equal to sigma upon epsilon. Okay. So now you tell me normal stress means tensile stress divided by tensile strain. Or normal stress means compressive stress divided by compressive strain. Okay. Or shear stress divided by shear strain. This is correct. Shear stress upon shear strain.
Yes, ma'am.
Yes. Anyone? Any other student? Shear stress divided by shear strain is correct or incorrect? Okay. We have studied two types of stresses. Now you tell me first type of stress and second type of stress. First type of stress, which one?
Normal or direct stress.
Normal or direct stress. And second one is,
Shear stress.
okay, shear stress. Now we have written here Young's modulus or modulus of elasticity means it is the ratio of normal stress to the normal strain. Okay, normal stress to the normal strain. So here shear stress upon shear strain, how it comes? No, this is second type. So here only normal stress, either tensile or either compressive. So only normal stress divided by normal strain. This is called as Young's modulus. Okay, please remember that Young's modulus or modulus of elasticity is denoted by using capital E letter. So E, which is equal to sigma upon epsilon. Normal stress, either it may be tensile or either it may be compressive. Okay. Now you tell me from that unit of this Young's modulus or modulus of elasticity. Unit of E. Unit of E. Is unit of
Dyne per centimeter square.
Please repeat once again.
Dyne per centimeter square.
Grand.
Newton per meter square.
Newton per
Meter
meter.
square.
Okay. How it comes? Okay, here stress upon strain, but you are saying unit is Newton per meter square. How it is possible?
Ma'am, pounds per square inch असतं.
Newton per meter square, it is also called as Pascal, but here stress upon strain, and you are saying the unit of Young's modulus is only Newton per meter square or Pascal. So how it,
Strain is unitless.
okay, strain has no unit or strain is unitless. Strain has no unit. That's why the unit of Young's modulus is same as stress. बघा स्ट्रेनला युनिट नाहीये त्याच्यामुळं Young's modulus आणि स्ट्रेस युनिट काय असणार आहे तुमचं सेम असणार आहे. सो बिलो राईट डाऊन युनिट ऑफ Young's modulus is unit of Young's modulus is Newton per meter square. Newton per meter square. Newton per meter square. Newton per meter square. And this is same as stress because of strain has no unit. That's why the unit of Young's modulus or modulus of elasticity is same like stress. Okay. Your writing is over.
Yes,
Yes,
ma'am.
Okay, please write down next point. Write down next point. Shear modulus. Next point is shear modulus, or this is called as modulus of rigidity. Modulus of rigidity. Modulus of rigidity. This shear modulus of or modulus of rigidity is shown by using G or C letter. G or C letter. G or C letter. First you write down definition, then I will explain. Write down definition. It is the ratio of shear stress to shear strain. It is the ratio of shear stress to shear strain. Shear stress to shear strain. is the ratio of shear stress to shear strain. Shear strain. Okay. So G or C, which is equal to G or C, which is equal to shear stress is denoted by using tau and shear strain is denoted by using gamma. Okay, G or C, which is equal to tau divided by gamma, or you can write tau, which is equal to G into gamma, or tau, which is equal to C into gamma, C into gamma. And below write down where tau, which is equal to shear stress, tau, which is equal to shear stress, G, which is equal to shear modulus or modulus of rigidity, shear modulus or modulus of rigidity, and gamma, which is equal to shear strain, gamma, which is equal to shear strain, gamma, which is equal to shear strain, gamma, which is equal to shear strain. Okay. In that way, we have studied two constants. First one is E and second one is G. So E means Young's modulus and G means shear modulus. Only one constant is remaining, that is bulk modulus. We will see later on. Please remember now only these two constants, E Young's modulus and G shear modulus or modulus of rigidity. Okay. If you are writing this word, shall I move towards next point?
Yes, ma'am.
Okay. Write down next point. Stress strain diagram. 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 You first draw this first one figure. Okay. Draw this first figure, then I will explain. Only draw this first figure. Huh? After your drawing is over, let me know immediately. I will explain this figure.
Oh, her ma'am.
Okay. So this stress strain diagram is basically for two different materials. Okay, for ductile material and for brittle material. So now you tell me what is meant by ductile material or ductility and what is meant by brittle material. What is meant by ductility? Anyone has no? Okay, rubber is a ductile material or brittle material?
Ductile. Logic.
Ductile. And glass is a brittle material or ductile material?
Brittle.
Brittle.
Brit.
Ductile means the ability of material which run into thin wires without failure. So rubber is a ductile material, steel is a ductile material, and brittle material means the material which fails suddenly without giving any indication or without giving any warning. This material is called as brittle material. So concrete is a brittle material, glass is a brittle material. Okay. So stress strain graph for two different materials, for ductile materials and for brittle materials. Now I will explain this figure 1. Okay. So on x-axis, strain is plotted here, and on y-axis, stress is plotted. In that, here two different curves are shown. Okay. So red curve shows this curve for ductile material, and blue curve shows this curve for brittle material. So what is the difference between this brittle and ductile material? See here. For ductile material, this material drawn into thin wires. Okay, here elongation is possible. In ductile material, elongation is possible, and after its load carrying capacity, it indicates my load carrying capacity is over, and after that, this material will get filled. But you observe in this brittle curve, this material fails suddenly. This material fails suddenly without giving any indication. So this graph is for brittle material. Okay. So in ductile material, elongation is possible. And in brittle material, there is no elongation. It fails suddenly without giving any indication. This is the basic difference between these two graphs. Okay. Got it? You have any doubt regarding this? If no doubt, shall I move towards the second figure?
Yes, ma'am.
Yes, ma'am.
Now please you draw this second figure and write heading stress strain diagram for mild steel. Stress strain diagram for mild steel. Stress strain diagram for mild steel. Draw this figure within 5 minutes, then I will explain. Okay, after drawing this figure, let me know, so I will explain. Draw very carefully figure. Huh?
Oh, her ma'am.
Wait, ma'am.
Okay, I will wait for 2 minutes again. Also.
Oh, her ma'am.
Okay, we will continue. I will locate points here. You can also locate here. Suppose here A point, here A, here P point, this is C, this is D point, this is E, this is F point, and this is last one, which is G. Suppose this is our O point. Okay. So first I will explain how this graph comes. म्हणजे हा ग्राफ कशामुळे प्लॉट करतोय आपण किंवा कशावरून जनरेट होतो. So this stress strain graph we will draw after taking tensile test on mild steel by using universal testing machine. Okay. So for that we have to this likewise this assembly is suppose this is fixture and this is rod is attached here and this is jaw. Okay. Here tension is applied, tensile load is applied, automatically here tensile load is applied. So after application of loading, this bar elongates. That means elongation is occurred. Elongation is occurred and length is going to increase. Okay, length is going to increase. After load carrying capacity, this rod breaks and we will stop this procedure. So this stress strain graph comes from tensile test on mild steel by using UTM machine. So this is called as universal testing machine. Which machine? Universal testing machine. Universal testing machine. So if we check tensile test by using UTM, then we are able to plot this graph. Okay. So this figure shows strain on x-axis and stress on y-axis. Okay. A figure shows strain diagram for a mild steel specimen. This figure shows strain diagram for a mild steel specimen. Okay. So now we will discuss O to A. Okay, we will discuss O to A point. So O to A point, this is linear point, and this line indicates slope of this line. Okay, slope of this particular portion. So this O to A portion is called as limit of proportionality. This O to A portion is called as limit of proportionality. Because of in that stress is increased. At that time, strain also increased. So, in this portion, stress is directly proportional to strain. In this portion, stress is directly proportional to the strain. Okay. If I remove this applied force, at that time, this material regains their original shape. म्हणजे तो त्याच्या ओरिजिनल शेपला जातो. That's why this is called as limit of proportionality. And within this limit, stress is directly proportional to the strain. That means stress is increased. At that time, strain also increased. So within elastic limit, stress is directly proportional to strain. And for this particular portion, O to A is called as limit of proportionality. This is called as limit of proportionality. After that, now we will move towards A to B. Okay, we will move towards A to B. Now, in A to B, okay, in this A to B, specimen is extended. Here stress is increased at some amount. Okay, stress is increased, and this is in elastic region. This is in elastic region, but here say there is no linear graph. बघा मी इथे तुम्हाला सेपरेट ग्राफ प्लॉट करून दाखवते. O to A straight line आहे, A to B and then B to. So up to this A point, line is linear. Okay, from A to B, elastic limit is present, but line is non-linear. Line is non-linear. But material is elastic. Material elastic आहे म्हणजे काय असणार आहे, त्याच्यावर आपण लोड अप्लाय केला आणि तो रिमूव्ह केला तर त्याच्या ओरिजिनल पोझिशनला तो रिगेन येणार. ओरिजिनल पोझिशनला रिटर्न येणार आहे. सो in between A to B, if we applied loading, at that time stress is increased, but the graph is non-linear. Okay, the graph is non-linear. So portion A to B is called as elastic limit. Portion A to B is called as elastic limit. Okay. After that, I will move towards this C point. Okay, this C point. From B to C. Okay, from B to C, stress is increased, but strain is not too much increased. Okay, so this is called as upper yield point. This is called as upper yield point. Here written upper yield point. So what is meant by yielding, or what is meant by yield? Okay, so yielding means it has started the change of shape or change in shape. Yielding means change in shape. From this C point, change in shape is occurred. So this C point is called as upper yield point. Okay. After that, you observe this D point. At D point, stress is decreases, but strain is increases. But strain is increases. So this D point is called as lower yield point. Lower yield point. Here stress is decreases. So at D point ला काय होते, तुमचा stress decrease झालेला आहे. That's why this point is called as lower yield point. Okay. After that, in between D to E, there is no increment in stress. There is no increment in stress. Only strain is increased. Only strain is increased. So this D to E portion is called as strain hardening. Strain hardening, or this is called as yield plateau. This is called as yield plateau. म्हणजे D to E portion मध्ये काय होते बघा, तुमचा स्ट्रेस वाढत नाहीये पण स्ट्रेन इनक्रीज झालेला आहे. ओके, so this is called as yield plateau. After that, next E to F. You observe here E to F. In between E to F, elongation is exceeded. That means stress is exceeded and you got maximum stress value. You got maximum stress value. So this is called as ultimate stress. This is called as ultimate stress. Okay. Here you observe stress is increases very sharply. Okay. Stress is increases very sharply. So you got maximum stress value and this point F is called as ultimate stress. Okay. Now you observe from F to G. Okay, F to G. So now load carrying capacity of this bar is over. So this bar going to break. Okay, this bar will going to break. That's why here necking region is formed. Necking region. So what is meant by necking region? See here. See our head and our shoulder. In between head and shoulder, one neck shape is there. That means the diameter of head and portion of our shoulder are very bigger, and in between that, our neck has very less dimension. So this is called as necking region. Here also there that mechanism is present. After load carrying capacity over, bars will get fail. म्हणजे त्याची लोड कॅरिंग कॅपॅसिटी संपल्यानंतर बार काय होणार आहे, फेल होणार आहे. मग तो त्याची वॉर्निंग देणार. म्हणजेच हा कुठला रिजन असेल तुमचा, नेकिंग रिजन. अँड दिस G पॉइंट इंडिकेट्स ब्रेकिंग स्ट्रेस और fracture point, at G point, our bar will be break. Our bar will be break. This is the stress strain diagram for mild steel. Okay. Once again, I will repeat here. O to A is limit of proportionality limit. In that, the graph is linear. In that, graph is linear. That is, stress is directly proportional to the strain. After that, A to B. After that, A to B. Here, graph is non-linear, but stress is increased. C point. This C point is called as upper yield point. What is meant by yielding? So if shape is going to change, so this is called as yielding. And this C point shows high value of stress or increased value of stress. That's why this is called as upper yield point. Okay. After C, this D point indicates stress will be reduced, but strain will be increased. म्हणजे इथे काय होते बघा स्ट्रेस कमी झालेला आहे पण स्ट्रेन तुमचा इन्क्रीज झालेला आहे सो दिस डी पॉइंट इज कॉल्ड एज लोअर यील्ड पॉइंट ओके आफ्टर दैट इन बिटवीन डी टू ई देयर इज zero stress that means increment of zero stress but strain is increased that's why this region is called as yield plateau after that E to F in that load carrying capacity is increased. So this stress is increased smoothly and sharp. That's why we got this curve. Okay. And this F point indicates we got maximum stress value. Maximum stress value. And from E to G, necking region is formed. And at G point, our bar will be break. Our bar will be break. Okay. For that, I will show you one video how to plot this graph by using which mechanism. Okay, please wait. Huh? Okay. My screen is visible to you?
Yes, ma'am.
Yes, ma'am.
Okay, I will show apparatus or how to perform this tensile test. And after performing this tensile test, we will able to draw this stress and strain curve. Okay. So this is the universal testing machine. On that machine, we are going to perform our tensile test. Okay. So in that, there are basically two units. Okay, two units. This is first unit, whole assembly. Yeah? This whole assembly. So this whole assembly first, this is called as loading unit. This is called as loading unit. This assembly is called as loading unit. And this second assembly is called as control panel. Okay, this second assembly is called as control panel. This second assembly is called as control panel. Okay, in loading unit, there are three crosshairs are present. So this is upper crosshead. This is upper crosshead. This is intermediate or middle crosshead. This is middle crosshead, and this one is lower crosshead. This one is lower crosshead. Okay. For middle and upper crosshead, there are two jaws. Okay, these jaws are provided for adjusting distance between two crossheads. Okay, this one, our loading unit. Please wait for 1 minute. Okay, this is first unit that is called as loading unit, and second is control panel. In control panel, here one dial is present. By using this dial, we are able to note load, how much load can carry by our rod. Here switches are given for starting and switch of the machine. Okay, so this is loading control panel. So from that control panel, we will apply hydraulic pressure on this rod, and after application of loading, we will see how to elongate the bar. This is the UTM machine. Okay, universal testing machine. This first equipment is required. This second equipment is required. This is called as extensiometer. This is called as extensiometer. This extensiometer is required to measuring deformation. This deformation is, we are unable to measure the deformation by eye visualization. That's why this extensiometer is used. After that, next equipment is required, that is vernier scale. Okay, so this vernier scale is required for measuring this diameter of our rod. After that, simple scale is required for measuring length of rod. So that, and this punching tool, you have to mark holes at 2.5 distance. Okay, so that much equipments are required for this. So now I will show you how to perform this test. Okay, now this is UTM. So first we have to measure diameter by using this vernier scale. Okay, along two directions, two perpendicular directions. So here diameter is measured. After diameter measuring, you have to measure length of this rod. Okay, length of this rod. After that, we have to mark holes at 2.5 distance by using these punching tools. Okay, 2.5 D. After finishing these punching holes, next step is we have to adjust distance between these two jaws. Okay, so when we are going to perform tensile test, at that time we are using this upper and middle crossheads, and when we are going to perform test, compression test or direct shear test, at that time we will use middle and bottom crosshead. Okay, so now we will use upper and middle crosshead. So I will arrange distance between them. Okay, after that we have to place this rod in between upper crosshead and middle crosshead. Okay, after placing, we have to adjust height between these two crossheads. So once again I will adjust height by using this knob. Okay, now our rod is fixed in between these upper and middle crossheads. Please wait for 1 minute. Okay. After that, after placing bar, we have to fix this extension meter. So I will fix here extension meters. Now our assembly is ready. Now I am requesting all students, please observe this code. Okay. Observe this figure. Okay, observe this figure. In that, you are going to able how rod will be break and how necking region will be formed. Okay. So I am requesting all, please see carefully. I will start machine here by clicking on the starting button. Okay, please observe the figure here. Now you observe elongation has started and here necking region is formed. Here necking region is formed and after load carrying capacity over, this bar breaks into two parts. Okay. Now I will stop machine. Got it? How bar will break, how necking region is formed, how elongation is started. So after that, we will get this curve. Okay, we will get this curve. So here, this point shows yield stress. This point shows yield stress and this point shows ultimate strength. Okay, ultimate strength. This graph shows what is the slope of this line. So after performing this tensile test, we are able to draw this stress strain diagram. How to perform this test? Okay, already I have shown you. Now I will move towards our next point. So आता लक्षात आले का तुमचा हा स्ट्रेस स्ट्रेन ग्राफ आपण कशावरून प्लॉट करतोय ते बार कसा चेंज होतो त्याचा डायमीटर कसा चेंज होतो हाउ टू इलॉंगेशन इज ऑकर्ड etc. Okay. Have you written the theory related to this stress strain graph? Yes, please. लिहिली आहे त्याची theory तुम्ही? When I am explaining this stress strain graph, at that time, you have written theory related to this stress strain graph or not? Anyone? Rohan, Mansi, Shweta?
No, ma'am.
Okay, please write down this because of this is most important part in our syllabus. लक्षात आले का हा स्ट्रेस स्ट्रेन ग्राफ कसा आहे आणि तो आपण कशावरून प्लॉट करतोय ते?
Yes, ma'am.
Okay, so please write down theory related to this. Write down. A figure shows stress strain diagram for mild steel specimen subjected to tensile test. Subjected to tensile test. Subjected to tensile test. Subjected to tensile test. Write down first point. The plot O to A, plot O to A, plot O to A is a straight line. Is a straight line. Plot O to A is a straight line. The stress corresponding to point, the stress corresponding to this point, the stress corresponding to this point, stress corresponding to point A, corresponding to point A is called as limit of proportionality. It's called as limit of proportionality. It's called as limit of proportionality. So after that, write down second point. Oh, no, sorry. Continue with this point number 1. Okay, this stress is called as limit of proportionality. Write down next line. Within this limit, within this limit, within this limit, within this limit, stress is directly proportional to strain. Within this limit, stress is directly proportional to strain. Within this limit, stress is directly proportional to strain. That is called as Hooke's law. 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 Okay, and write down this expression. Stress is directly proportional to strain. So stress which is equal to E into epsilon. E into epsilon. Okay. After that, write down second point. Second point. If specimen is exceeded, if specimen is extended between A and B, if specimen is extended between A and B, material is still elastic. Still, S-T-I-L-L. Material is still elastic. Material is still elastic. Still elastic, but relation between A and B, relation between A and B, relation between A and B, stress and strain is not linear. Stress and strain is not linear. Stress and strain is not linear. Stress and strain is not linear.
मॅम नॉटच्या नंतर कोणता वर्ड
Linear, linear. L-I-N-E-A-R. Not linear. Full stop. The stress at B. The stress at B is called as elastic limit. The stress at B is called as elastic limit. The stress at B is called as elastic limit. Full stop. if the specimen is extended beyond the limit, if the specimen is extended beyond the limit, specimen is extended beyond the limit, beyond the elastic limit, beyond the elastic limit, the plastic deformation takes place. Plastic deformation takes place.
Ma'am,
Hmm?
sentence repeat सांगा.
Okay. If specimen is extended, if specimen is extended beyond the elastic limit, beyond the elastic limit, beyond the elastic limit, beyond the elastic limit, the plastic deformation takes place. Plastic deformation takes place. Plastic deformation takes place. Plastic deformation takes place. Full stop. In the range between B to C, in the range between B to C, in the range between B to C, B to C, strain increases, strain increases, strain increases with almost constant stress, with almost constant stress. Okay, you observe here in between B to C, strain is increases, but stress is almost constant. म्हणजे B आणि C मध्ये स्ट्रेस हा कॉन्स्टंट दिसतोय पण स्ट्रेन काय झालेला आहे इथे इनक्रीज झालेला आहे. ओके, सो विथ ऑलमोस्ट कॉन्स्टंट स्ट्रेस. So at point C, at point C, at point C, stress is called as upper yield point. At point C, stress is called as upper yield point. Upper yield point. Okay. After that, write down third point. Third point. The condition at D, the condition at D, the condition at D, material offers resistance, material offers resistance, material offers resistance to a greater extension, to a greater extension, to a greater extension, to a greater extension. Full stop. The stress at D, the stress at D, the stress at D is called as lower yield point. Lower yield point. Lower yield point. Okay, after that, write down fourth point. Fourth point. As load is increased, as load is increased, as load is increased, the extension increases. The extension increases. extension increases. That means elongation. So here stress is increases. As load is increased, the extension increases. Extension increases at the condition shown in E. At the condition shown in E. At the condition shown in E.
At the condition नंतर
At the condition shown in E. At the condition shown in E. Full stop. At the condition shown in E. Full stop. A waste, a waste, making a waste or making is developed in the specimen. 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 In the specimen. In the specimen. Developed in the specimen. Full stop. The stress corresponding to this E, stress corresponding to E, stress corresponding to E, stress corresponding to E is called as ultimate stress. Is called as ultimate stress. Ultimate stress. And write down last point. As the extension increased, as the extension is increased, the load required decreases. Load required decreases. That means elongation is increases. At that time, load carrying capacity will be reduced. म्हणजे त्या बारचं elongation जर जास्त झालं असेल तर त्यावेळी ऑटोमॅटिक त्याची लोड कॅरिंग कॅपॅसिटी काय होणार आहे तुमची कमी होणार आहे. So as the extension is increased, the load required decreases and the specimen breaks. And the specimen breaks at point F. Breaks at point F. At point F. Full stop. The stress at F. The stress at F is called as. It's called as. It's called as. The stress at F is called as breaking stress or failure stress. 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 Over. Your writing is over.
Yes, ma'am.
Okay. Now we will move towards next point. If anybody have any doubt in this stress strain graph, please ask me, because of this stress strain graph is more important in our whole subject. So if you have doubt, ask me, I will clear. Otherwise, we will move towards next point. Okay. If no doubt, I will move towards next point. Please write down next point is Poisson's ratio. Poisson's ratio. Poisson's ratio. Okay, draw this figure and let me know after drawing. Okay, you are drawing this over. Shall I continue?
No, ma'am. 1 minute.
Okay, draw fast.
Over, ma'am.
Okay. So Poisson's ratio is a material property. Okay. Poisson's ratio is a material property, and this is the ratio of lateral strain to longitudinal strain. So now we will see what is meant by lateral strain and what is meant by longitudinal strain. So I have taken here one rod. Suppose I have taken here one rod. I will draw figure so you will able to understand easily. Suppose I have taken rod here and I am going to apply load. This is rod AB and I am going to apply load on that rod. Suppose this is circular rod, diameter is there. This is also circular rod, so diameter is there. So I am applying tensile load. Here I am applying load. So after application of loading, length will be increased. After application of loading, length will be increased, but perpendicular dimension has reduced. Perpendicular dimension has reduced. So perpendicular dimension is D, diameter. If length is increased at that time, another dimension is going to reduce. So suppose I am going to apply load along axis at that time perpendicular dimension is reduced. So this strain is called as lateral strain. That means if dimension is changed with respect to diameter, this is called as lateral strain. Okay. And when we say longitudinal strain, if dimension is changed with respect to L or with respect to axis, then this strain is called as longitudinal strain. Okay. So Poisson's ratio is the ratio of lateral strain to the longitudinal strain. Length is increased, then longitudinal strain. Diameter is reduced or diameter is increased. So this is lateral strain. Lateral means along diameter and longitudinal means along the application of loading. So Poisson's ratio, write down definition. Poisson's ratio is the ratio of lateral strain, lateral strain, lateral strain to the longitudinal strain or axial strain. This is called as axial strain. Axial strain. Lateral strain to the axial strain. Lateral strain to the axial strain. Okay. Lateral strain to the axial strain. So write down mathematically. Mu which is equal to lateral strain, that is epsilon y divided by longitudinal, that is epsilon x. Y means with respect to y axis and x means with respect to x axis, that is longitudinal strain or axial strain. Mu which is equal to epsilon y divided by epsilon x, where epsilon y which is equal to original diameter minus change in diameter divided by original diameter. Okay, this is called as lateral strain. Strain nothing but change in dimension upon original dimension. Okay. And how I will write epsilon x, which is equal to change in length to the original length. So change in dimension upon original dimension. So please remember that Poisson's ratio is the ratio of lateral strain to the longitudinal strain or axial strain. Longitudinal strain or axial strain. You are going to giving any competitive exams related to direct recruitment. In that examination, one question definitely asked. So, what is meant by Poisson's ratio? What is Poisson's ratio? What is Poisson's ratio? And options are given. Lateral strain to the longitudinal strain. Okay, this is called as longitudinal, axial, or linear also. Huh? Linear strain. This is A option. B option is given linear to lateral. Linear to lateral. C option is given linear to axial. Linear to axial. And maybe D option is given longitudinal to the lateral. So at that time you have to choose correct answer. So please remember that lateral to linear, okay, or longitudinal or axial. So definitely one question is going to ask. This is first question. Now I will tell you second question. The value of Poisson's ratio for engineering material varies from 0 to 0.5. This is most important point. So please write down this. The value of Poisson's ratio for engineering material varies from 0 to 0.5. 0 to 0.5. Now you tell me the maximum value for Poisson's ratio, which is how much? The maximum value of Poisson's ratio for engineering material, which is how much? किती असणार आहे हो maximum value?
0.5.
0.5. This thing is most important. Okay. The value of Poisson's ratio for engineering material is 0.5 is maximum and minimum is 0. Okay. So this is Poisson's ratio. I will write here some values for Poisson's values for different materials. So you can also write down steel. For steel, value of Poisson's ratio mu. So value is 0.25 to 0.33. Okay. When you are solving problems at that time, suppose you choose the value of Poisson's ratio for steel material is in between 0.25 to 0.33. Then second material is cast iron material. Cast iron material. So for cast iron, mu is 0.23 to 0.27. 0.23 to 0.27. After that, third material is concrete. Concrete. For concrete material, Poisson's ratio is 0.2. 0.2. For rubber, Poisson's ratio is 0.48 to 0.5. 0.48 to 0.5. After that, cork. For that, nearly about 0. Nearly zero. Okay. These are the values for different values of Poisson's ratio for different materials.
Ma'am, second question.
Cast iron. Cast asked either. Okay, from that, one important thing you have to remember that values of Poisson's ratio for engineering material vary from 0 to 0.5 and maximum value is 0.5. Formula for Poisson's ratio is lateral strain to longitudinal strain. Okay. You have doubt? If your writing is over, for today we will stop here. If your writing is over, please don't leave the meeting. Huh? Now mark your attendance in chat box. Okay. Thank you for attending lecture. We'll stop here. Next point we will continue in next lecture.